So the actual expression that relates voltage and current through a resistor is called Ohm's law, okay? And what it basically says is that the voltage that develops across a resistor is proportional to the current that's running through it, linearly proportional. And the proportionality constant is the resistance, is R. So V equals IR. This is something every electrical engineer learns early on. V equals IR. And so the notion is pretty easy. It follows the pipe, and you see the symbol up there for the symbols as givens, for V written that way and I given that way. You can always use this expression V equals IR to relate the voltage across the resistor, just across the resistor, to the current flowing through the resistor. All right? Fair enough?
Yeah, it sounds pretty good, but yeah.
Okay.
V equals IR, that's quite simple.
Okay, but that doesn't seem weird to you?
What do you mean weird? V equals IR, that's very simple, and
All right.
I like that.
Okay, hold on. So let's go back to physics. Let's say I take a charge and out in free space, out in outer space, and I put in an electric field. So there's a potential, right? It's some electric potential, right? I put in an electric field. Do you remember what's going to happen to that charge?
Yeah, I do remember. So that charge in an electric field will have a force.
There's a force acting on it.
It's the electric force, and that F is equal to E, the strength of the electric field, times Q, the charge on that charge. And that charge will start accelerating in the direction of the force because F equals ma. And so it will wait a second. If this charge is going to accelerate, that doesn't make sense because now V equals IR does not make any more sense. That relationship is no longer linear if we're accelerating very quickly. It's like dropping a ball and watching it get faster and faster and faster.
Right. The electrons should just get faster and faster. You know, maybe they hit the speed of light or something. But Ohm's law would seem weird if that was happening. So it turns out that what happens is these electrons are actually in a wire, right?
That's right.
And so you apply a potential across this wire, and yeah, the electron's going to accelerate. But you think anything's going to happen as soon as it accelerates? Any guesses?
Well, yeah. Okay. So when we're talking about physics, we're usually in this fantasy world where we're in free space and the charge isn't going to hit anything. But when we're in a wire, it's probably pretty crowded with atoms of the metal or whatever the conductor is.
Exactly. So basically what's going to happen is these electrons are going to quickly accelerate and almost as quickly hit something. That something is one of the atoms of the metal. Now, by the way, they can also hit other electrons, which is an interesting topic all on its own. But let's say it hits one of these atoms of the metal. So it smacks into it and it dumps some of its energy into the atom. The atom's going to vibrate a little bit, and actually that is effectively heat that's giving off. It's transferred energy, and so it warmed it up. But it's still in the potential, right? Because we still have that voltage across the resistor or the wire, and so it accelerates again. And so basically what's happening, the way to think about this, what's happening in a wire is that there's billions and billions of these electrons constantly just like, woo, you know, they accelerate and they smack something, accelerate and they smack something.
That sounds endlessly frustrating.
Right. So, you know, think about like a ball. Instead of dropping it in free space, think about a ball you drop through a forest of pegs.
Oh, like a pachinko machine.
I don't know what pachinko is, but I'll take your word for it.
Yeah, so if you drop, well, a pachinko is a game where if you drop a ball, you drop it through a series of pegs, and it hits each peg and bounces and bounces.
Yeah, exactly.
And bounces.
That's right.
So instead of getting faster and faster and faster,
it just
as
goes
it
boom,
falls,
boom, 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 boom.
Exactly, it
That's
falls
right.
at a constant rate.
That's it. That's Ohm's law.